Long before we had broadband, there was this one technology that promised to do it all, send voice, video, and data all down a single ordinary phone line. It was called ISDN, and you know what? Its DNA is still kind of hidden inside the internet we use today. So let's deconstruct it.
I mean, it sounds kind of impossible, right? Think back to when dial-up modems were screeching just to send a simple email. How in the world could one phone line handle everything at once? Well, this wasn't just some minor upgrade. It was a total rethinking of what a phone line could even do. And the solution had a name, ISDN, the Integrated Services Digital Network.
The core idea behind it was actually brilliantly simple. You take the standard copper phone line that everyone already had, and you turn it into a digital pipe. So instead of one crackly analog conversation, this pipe could be split into dedicated channels. You could have one for your voice call, one for data, maybe another one for video, all running at the exact same time. This was the blueprint for a truly unified digital future.
Okay, so how did it actually juggle all this traffic without everything getting tangled up? The secret is in its architecture. It's split into 3 conceptual layers, or what we call planes. Honestly, the best way to think about it is like the network's own little operating system, where each plane has one very specific job to do.
And the flow is just incredibly logical when you break it down. First, you've got the user plane. Think of this as the multi-lane highway where your actual stuff, your voice, your files, is traveling. Then you have the control plane, which is like the traffic control center, setting up the connections, giving the green light. And finally, there's the management plane. This is like the highway patrol, constantly monitoring everything to make sure the whole system is running just like it should.
So here's the more formal breakdown you might see. But the real key takeaway, the most important thing to get, is the separation of these jobs. By keeping the actual data transfer separate from the call setup and from the system monitoring, ISDN made the whole network way more efficient and resilient. One plane could have a problem without bringing the entire system crashing down, and let me tell you, that design principle is absolutely critical in the internet we use today.
All right, so we've got the operating system down. Now, let's meet the physical hardware, the cast of characters that actually makes an ISDN connection possible in your home or your office.
Let's break down this hardware. First, you have your devices, which are called terminal equipment, or TE for short. Then, for your older, non-digital stuff, you have translators called terminal adapters, or TAs. And finally, you have the gateways that connect you to the phone company's network. Those are called network terminations, or NTs. See, each piece has a very distinct job.
Now, the difference between a TE1 and a TE2 is really crucial. A TE1 device, like a special ISDN phone, is basically a native speaker. It already understands the digital language of ISDN, so it can just plug right in. But a TE2 device, think of your old analog telephone or fax machine, it doesn't speak the language. It needs that TA, the terminal adapter, to act as a translator for it.
The gateways to the network, the NT1 and NT2, also have a pretty simple split. The NT1 is the basic box you'd have at home. Its only job is to connect you to the main phone line. But the NT2, well, the NT2 is a lot smarter. Think of it like a mini telephone exchange for a whole office, kind of like a PBX system. It manages all the internal lines before it connects the entire office to the outside world. Okay, so we have the planes and we have the equipment. But how do they all physically connect to each other? This is where ISDN's famous reference points come into play. These are basically standardized interfaces that define exactly how each piece of hardware is supposed to talk to the next one. And luckily for us, there's a perfect little mnemonic device to remember the order of all these connections. RSTU. Just think, remember, sequence to understand. Seriously, this little phrase is the key to mapping out the entire ISDN chain.
So, we start with R. The R reference point is only for non-ISDN gear, those TE2 devices we talked about. It's the interface between, say, that old analog phone and the terminal adapter that has to translate its signals. You can just think of it as the standard old-school phone jack connection. So, our blueprint starts right here. The non-ISDN device, the TE2, sends its analog signal across that R interface to its personal translator, the TA. This is the very first link in our chain. Next up in the sequence is S. The S point is the main hub for all the user's equipment. Your native ISDN device, the TE1, plugs directly in right here. And this is also where the terminal adapter, after it's done translating that analog signal, comes to join the digital party.
And just like that, our diagram evolves.
See how everything comes together at the S point? Both the native digital devices and the newly translated analog devices are now speaking the same language, and they are ready to connect to the office switch, the NT2.
After S comes T. Think of the T reference point as the final boundary inside your building. It's the line that separates your local office switch, the NT2, from the NT1, which is the very last box before your signal heads out into the wider world.
So adding T completes the user side of the network. And it's worth noting, for a typical home setup where you don't have a big office switch, you just have that single NT1 box. On those, the S and T interfaces are usually just combined into one port because there's no internal switching that needs to be separated.
And that brings us to the final piece of the puzzle, U. The U reference point is the digital pipe itself. It's the physical, two-wire copper line running from your building all the way to the phone company's central office. This is it, the final link that connects you to the entire network.
All right, now that we have all the pieces, the equipment and the interfaces, we can finally put them all together and see the complete and frankly pretty elegant blueprint of an ISDN connection.
And there it is, the complete path. So imagine you're sending an analog fax. It starts at the TE2, gets translated by the TA across the R point, joins the main user network at the S point, flows through the office switch, crosses the T point to the network gateway, and finally travels out to the world on that U line. What about a native digital phone? Well, it gets to skip the whole translation step and just jump right in at the S point. It's a beautifully logical flow.
This slide really puts it all into perspective, doesn't it? On the left, you've got the why, the conceptual planes that organize all the work. And on the right, you've got the how, the physical interfaces that actually connect all the hardware. Together, they form a complete model for digital communication.
So what's the ultimate takeaway here? The crucial point is that ISDN was never just a faster version of dial-up. It was a complete, standardized architecture for digital services. It proved you could reliably run voice, data, and video over a single infrastructure. And in doing so, it created the blueprint that modern broadband and the internet itself would eventually be built upon.
And that really brings us to today. The ISDN hardware itself might be gone, but its core philosophy is absolutely everywhere. That fundamental idea of separating the data, what you send, from the control, how you send it, is the bedrock of nearly every modern network. So the next time you're on a video call while downloading a huge file, think about this old blueprint. Where else do you see its echoes?